Good morning, students. Today we are going to discuss about forelimbs. The forelimb of vertebrates shows structural similarity but performs different functions in various animals. This is an example of homologous organs showing divergent evolution from a common ancestor from fishes to mammals. The forelimb has undergone progressive modification and specialization, reflecting evolutionary adaptation to different modes of life: swimming, walking, flying, running, or grasping. So, forelimbs in fishes. In fishes, forelimbs are modified into pectoral fins. The bones are mostly cartilaginous or bony rays supported by girdles. Pectoral fins in elasmobranch fishes. One pair of pectoral fins are present in elasmobranch fishes. They are located just behind the gill slits. The base of each pectoral fin is supported by three cartilages called protopterygium, mesopterygium, and metapterygium. These three articulate with three little facets, forming the glenoid surface at the junction of scapular coracoid portions of pectoral girdles. The middle part of fin is supported by three rows of cartilages called somatidia. The distal part of fin is supported by a series of horny, unjoined rays called as ceratotrichia. Pectoral fins in bony fishes. The bony fishes, each pectoral fin is supported by bony, jointed 19 fin rays are proximally jointed with 4 radials or somatida, 3 of which attached with glenoid articulations of scapula and coracoid. Forelimbs in tetrapods. Tetrapods are superclass of vertebrates that includes all animals with 4 limbs. Tetrapods includes 4 main classes of vertebrates: amphibia, reptilia, aves, mammalia. Tetrapods evolved from lobe-finned fishes and developed 4 limbs for life on land. Even though birds and some mammals do not have the typical 4-legged structure, so they are still classified as tetrapods because they evolved from 4-limbed ancestors. So, basic plan of tetrapods: 4 limbs. Despite differences in appearance and function, the basic skeletal pattern of 4 limbs remain the same across all tetrapods due to a common ancestry. A tetrapod 4 limbs follows pentadactyl limb plan. A typical tetrapod 4 limb consists of 3 main regions. They are upper arm, forearm, manus. So here observe this picture. Basically a plan of tetrapod 4 limb: upper arm, forearm, manus. In upper arm, the upper arm composed of a single bone called as humerus. It connects proximally with the glenoid cavity of pectoral girdle and distally with radius and ulna. Forearm. The forearm composed of 2 bones, radius and ulna. Manus. The manus composed of 3 types of bones: carpals, metacarpals, phalanges. Primitively, the carpals were in 3 rows. The proximal rows of carpals located just below the radius and ulna are 3 in number. They are called radial, intermedium, ulnare. The central carpals are centralia, located in between the proximal and distal carpals. In modern forms, there are two bones in centralia. The distal carpals are 5 in number. They are called carpalia. The metacarpals are located in palm region. It is supported by metacarpals. Beyond the palm lies the fingers. The fingers are supported by phalanges. Next, observe this screen. So, comparison of forelimbs in tetrapods. Forelimbs in amphibians, reptiles, birds and mammals are pentadactyl type. They have same structure but they do not different functions. They do different functions. Sorry. They have same structure but they do different functions. The forelimbs of a frog is used for hopping. In reptiles, forelimbs are used for crawling. In birds, forelimbs are used for flying. In mammals, forelimbs is used for running, flying, swimming, for doing non-locomotory functions. Across all vertebrates, the forelimbs is made of three main parts: upper arm, forearm and manus. The manus or hand comprising wrist, palm, fingers. The upper arm in all tetrapods is built from a single long bone called as humerus. In birds, it is pneumatic. The forearm contains two bones, radius and ulna. In amphibians, these two bones are fused, forming the radio-ulna. In reptiles and birds, they are separated. In mammals, these two bones are placed close together. In bats, the ulna is reduced. The wrist is composed of carpal bones. Frog has 6, Caelotis has 8, birds have 4, mammals have 9 carpal bones. The palm includes the metacarpals. Frog, Caelotis and mammals have 5 metacarpals. Birds typically having only 3 metacarpals. In birds, the distal carpals and metacarpals fuse to form the carpometacarpus. In bats, the carpals and metacarpals are elongated to support the wing. Regarding digits, frog possess 4 digits. Reptiles and mammals have 5 digits. Birds usually show 3 digits. In ungulated mammals like horse, pigs, camels having hoofed. Ungulated means hoofed. Mammals like horse, pigs, camels. The digits are reduced in number. In pigs, camels, there are only 4 digits. Digits 3 and 4 are usually elongated, while digits 2 and 5 are reduced. Horse has only 1 digit, that is middle digit. In primate, the first digit is called pollex. It is independent of other digits. Regarding digits, in amphibians only 4 digits are present besides a rudimentary pollex enclosed in the skin. In reptiles, there are 5 digits ending in claws. In birds, there are 3 digits. In mammals, are 5 digits ending in claws. The phalangeal formula is frog 02233, Caelotis 23443, pigeon 12100, man 23333. So this is the structure and functions of bones that is 4 limbs. Thank you.